questions. So question number 31 is, which statement about orbitals in Krypton atom are correct? So we've got Krypton over here, and Krypton is the 1s and 2s orbitals have the same energy as each other but different sizes. So the first, we haven't done ionization energies. We're going to do that, probably start now. Okay. So we'll just do a few more questions on electronic configuration, and we're going to start with ionization energies. Now this one is the 1s and 2s orbitals don't have the same energy level. One is the shell number is different. Shell number represents the energy level or the principal quantum number. So they're not going to have the same energy level. So option number 1 is incorrect. The third energy level has 3 subshells and 9 orbitals. That is correct. Like if you go and have a look at the Aufbau principle, so the Aufbau principle had where's the Aufbau principle? If you look at the third shell, you would notice that it's got 3s, 3p, and 3d. There are how many orbitals in 3s? That's just 1. This is 3 orbitals, 3px, 3py, and 3pz. And this is 5 orbitals, 3dxy, 3dxz, 3dyz, 3dx² minus y square, and 3d. So there are 5 orbitals over here in this subshell, 3 in this one, and just 1 in this. So that is a total of 9 orbitals. 5 plus 3 plus 1 in this. So this statement, okay, that it has 3 subshells, it does. It has 9 orbitals, that is also correct. And then you have the 3D subshell has 5 orbitals that have the same energy level as each other, and that is also correct. The 3D subshell has 5 orbitals, which have the same energy, which are degenerate. These were we did make the drawing. Okay, the S subshell just has 1 s orbital. The P subshell has 3 different orientations. That's 3 orbitals. And the D actually has 5 of them. You don't need to remember the shape of this, but what you need to remember is that the 3D subshell has 5. The electron is going to be distributed in 5 different ways. The next one is, so for this one, it's 2 and 3 that are going to be correct. The next one is, remember now in your MCQs, you're not going to get these types of questions. It's just going to be A, B, C, D. But these are old past paper questions. So previously you had 1, 2, 3 statements in which any one of them could be correct or multiple can be correct. Now, which statement about orbitals in a krypton? I mean, this is the same question repeating. This one, which statement about the atoms of sodium and magnesium are correct? Sodium is 11. So 11 electrons is 1s2. And it's 2s2 and 2p6, and it's going to be 3s1. Magnesium is pretty much going to be the same. It's 12 electrons, so it's 1s2, 2s2, 2p6, and then there is 3s2. So they have the same number of filled electron orbitals. So that is correct. They have the same number of filled orbitals. So all of, I mean, it's just 4 orbitals in each case. Then they have the same number of neutrons, which is also correct that both of them, it's 11 and 23. This is 24 and 12. So the number of neutrons is the difference. So that is also correct. They're both reducing agents, which means reducing agents, they get oxidized, although this is not to do with electronic configuration. But reducing agents, they like to get oxidized, which means that they lose electrons. And since both of them, Na and Mg, are metals, so they like to lose electrons. Metals always like to lose electrons. They always like to form positive ions. So that statement is correct. All metals, they actually are pretty good reducing agents because they like to lose electrons. They like to get oxidized. Then the next one is an isolated gaseous atom of element X has paired electrons in at least one of its 3D orbitals and has a filled 4s subshell. So which could be this metal? So the first one is iron. It's 26 electrons. So that's 1s2, 2s2, and 2p6 and 3s2 and 3p6 6, and then it's going to be 4s2, that's 20 electrons, and then you have 3D, which is going to have 6 electrons. So the question was that it should have a filled 4s subshell. So it's got a filled 4s subshell, and the 3D must be, at least one of its 3D orbital must be paired. And that is correct, because remember how to fill a subshell, that there are 5 orbitals for 3D. And there's a 3D Z square. So electrons are always filled in a subshell in a single manner first. And since there are 6, so the first one is going to be paired. Then you have gallium. Now for gallium, what you need to do is, gallium is, where's the pure table? Just a second. It's probably in group 3. So let me open the pure table. So gallium is in group 3. Now, so what would be the electronic configuration of gallium? You can either write the whole of it, but remember yesterday we talked about calcium. You can start with calcium that, you can write actually 31. For 31, it's going to be, because you've written iron's electronic configuration. So instead of using the shortcut, because gallium is 31. So for 31, everything would be the same, except that at the end, so everything would be exactly the same, except at the end, it's going to be 3D10 and 4s2, and then there's going to be 1 electron in the 4p. There's, compared to iron, there would be 5 extra electrons. So 4 would fill up so that's 3D10, that's 30 electrons. And after that, it's going to be 4p. So the 4s is filled and the entire 3D is paired. So at least one should be paired. So that is also correct. Then you have copper. Now for copper, it's the issue is that copper is one of our special cases, which we had discussed earlier somewhere. Yahan pe, this is copper, 29 electrons. So I told you that there are 2 special cases that don't follow the Aufbau principle completely. They almost follow it, except that at the end, instead of being 4s2 and 3d9, it's actually 3d10 and 4s1, which is why this can't be correct, because he said that the 4s was filled, and in this case, it's not filled. So for copper, the 4s is not filled. It should have a filled 4s subshell, which in this case it's not. So only 1 and 2 are correct for this. This one is, is this clear? Quick questions, any questions? Anyone? So this one, which isolated gaseous atom has a total of 5 electrons occupying spherically shaped orbitals? So basically s orbitals, spherically shaped. So you need 5 electrons in the s orbital. So the answer to this is sodium, because sodium is 1s2, 2s2, 2p6, and 3s1. So it's got 3 s subshells. All of them have different energy levels, but the first one has 2, the second one has 2, and the third one has 1 electron in it. So it's a total of 5 electrons in spherically shaped orbitals. Then you have that 4 electronic configurations are given, and they belong to the atoms chlorine. Now chlorine is in group 7 or 17. So chlorine's electronic configuration is going to end with s2 and p5. So which one is chlorine? Chlorine is this one. This is Cl. Sodium is group 1. Group 1 is going to be s1. So this is sodium. And then you have vanadium. So for vanadium, last time we discussed that you're going to vanadium is going to be, where's the pure table? So calcium is 4s2, and then they told you that after 4s2, I mean, it's the fourth shell, and calcium is in group 2, so it's 4s2. After 4s2, we had discussed the shortcut for transition metals that the D starts filling up. So it's going to be 3D1, 3D2, and 3D3. This is something that we had discussed yesterday about. Okay, for transition metals, you should know that calcium ends at 4s2, and right after 4s2, when you want to figure out the electronic configuration of transition metals very quickly, after 4s2, the 3D starts filling up. So it's 3D1, 3D2, 3D, 3, and I think I got the order wrong over here. Just a second. Where's the? It's titanium, vanadium. So, I mean, this needs to be corrected. Just a second. So you've got titanium, then vanadium. Anyway, so vanadium is going to be 3D3. So very quickly, it's 3D3. This is vanadium, which is 3D3. And he was asking to figure out the electronic configuration which belongs to an atom of another element. So it's the only option left with you is D, because we've been able to figure out all the electronic configurations. Remember, for questions like these, you're going to waste a lot. You have to be very quick in your MCQs. So make sure you know how to spot electronic configuration or quickly tell what the electronic configuration is. Sodium is group 1, so that's S1. Chlorine is group 17, so that's S2 and P5. Vanadium is the transition metals, and so you start with calcium, which is 4s2, and then it's going to be 3D1, 2, and then 3. So the only one left is this D, which is over here. Similarly for this, remember you have to be very quick. I mean, this question, you can't waste time. Look at one way to do this is you open the periodic table and you start writing each electronic configuration. The other one is be quick. Remember, it's 4s2. And they didn't even give you the complete electronic configuration to begin with. So 4s2, and then it's 3d5. So what the quickest way is, this is 4s2, then 3d5, 3d1, 3d2, 3d3, 3d4, and this is 3d5. So it's manganese. So remember, this is what we did. So remember, you've got to be quick, and the answer to this is manganese, Mn. You're not going to, you have to avoid wasting time. TK, you don't have time for this. TK, is this clear? Taj, is this clear? Rizwan, sorry. Alicia, Amna, is this clear? Aisha?
Yes, sir.
Yes, sir.
Just similarly, which ion has the same electronic configuration as Cl-1? So same electronic configuration, the one has the same number of electrons. Cl-1 is 18 electrons. I mean, Cl has 17 electrons, -1 means 18 electrons. So it's going to be scandium, which is, scandium is 21. 3 plus means that it also has. So remember, atoms having the same electrons would obviously have the same electronic configuration. Now this one is, which of the following particles would on losing an electron have a half-filled set of p orbitals? Remember, whatever the substance is, it's got to lose electrons. All of them have to lose electrons on losing an electron. So the first thing is we need to figure out how many electrons do they have in the first place. Carbon is proton number 6, but it's -1. So it basically has 7 electrons. Nitrogen is 7 electrons. I mean, its proton number is 7. Nitrogen -1 is going to have 8 electrons. There's going to be 1 extra electrons. Oxygen had 8 electrons, but now it's going to be, it had 8 electrons, but now it's going to be 7 electrons because it's +1. So remember, all of them, these are the actual number of electrons of the particles that I mentioned over here. Now they're supposed to lose electrons. So this one would be 6 electrons. This one would also be 6 electrons. This one would also be 6 electrons. And this would be, so all of them have lost electrons. So who has, on losing electron, have a half-filled set of p orbitals? It's going to be 7. It's because 7 electrons is 1s2, 2s2, and 2p3. So your p orbital, your p orbitals are half-filled. 2px, 2py, and 2pz. They're all partially filled. So let's what's the electronic arrangement of the nitrogen ion? That's kind of easy. Nitrogen forms a -3 ion. So that's 10 electrons. You write the electronic configuration of 10 electrons, which is going to be this one. In which pair? So this is about radius, so forget that for now. Now this question is, which graph represents the number of unpaired p orbital electrons for atoms with proton number 13 to 18? So remember, he's talking about unpaired p orbitals. So 13 to 18. Now 13 is what? It's proton number 13, 14, 15, 16, and 17 and 18, so on. So I'll just relate this, instead of writing the whole electronic configuration, I'll just relate it with the group number. So 13 electrons is basically aluminium. It's in group 13. So 13 is in group 13, 14 is in group 14, 18, the one with 18 electrons is in group 18. So I'll just relate it to this. So 13 would have an electronic configuration of S2P1. 14 would have an electronic configuration of S2P2. 15 would have an electronic configuration S2P3. Then you have S2 and P4, and then you have S2 and P5, and then you have S2 and P6. So I've figured out all the electronic configurations, 13 to 18. Now the question is not about the electronic configuration. The question is about the number of unpaired electrons. So the p subshell has just one electron. So that means you have px, py, and pz. So p having one means the other two are empty. So it's just going to have one electron. P2 means that px, py, and pz would be two unpaired orbitals. P3 means that there are going to be three unpaired. So if you have P3, it's going to be px, py, pz, and each one would have one electron. When it comes to P4, then the number of unpaired decreases. It comes back to 2 because one of them is now paired. When it comes to P5, the number of unpaired decreases again. It comes to 5 electrons in the P would mean that there's only one unpaired. When it comes to P6, then that means there's going to be 0 unpaired. So the graph would go up and then it's going to go down. Because remember, you're focusing, he wanted to know the number of unpaired electrons. So the P became unpaired, 1 unpaired, then 2 unpaired, then 3 unpaired, and then the pairing started. So the number of unpaired, they started to decrease. Okay, is this clear? Sidra, is this clear? Raid, Oswa?
Yes, sir.
Now, so what is it? What could be the proton number of an element that has 3 unpaired electrons in each of its atoms? It's a 3 unpaired. So basically it's P3, S2, P3. When do you have S2? So when do you have S2, P3, 3 unpaired? Remember S.
15.
Okay, so it's going to be 15. It's going to be group 15. So what could be the proton number? It's probably going to be 15 because that's phosphorus. It is in group 15. अच्छा जल्दी से बताओ which group is this in? I mean,
Group 6.
नहीं, S2P6, S2P6, S2P6 is group 18.
तो लेकिन वो ओ लेवल्स वाले का तो 6 ही बोलेंगे ना, मतलब इस तरीके से तो 18 ही है
नहीं, group
मतलब
6, नहीं नहीं, O levels
सर
group
ऑप्शन
ना
जी
वो group 6 जो है ना, that is now 16. It's not 18.
अच्छा
Clear?
ठीक है यस सर
तो मतलब वो group 18 is your noble gases, ठीक है? Remember, noble gases is S2P6, ठीक है? अच्छा, this one, in which pair do both species have the same number of unpaired p electrons? So first one, oxygen is group 6, ठीक है? So I'm not going to write the electronic configuration. It's going to be क्या था, group 6 is S2P4, right? अच्छा, Cl is group 17, so it's S2 and P5. But remember, it's +1, so that means it's lost one electron. So instead of P5, it would be P4. So both of them will have exactly the same electronic configuration. This would be S2P4. This was supposed to be S2P5, but since it's +1, that means it lost an electron. So they have exactly the same electronic configuration. So they would have the same number of unpaired p electrons as well. So then the next one, you've got fluorine +1. Now fluorine is group 17, so it should be S2P5. But it's +1, so that means it's S2P4. And gallium is -1. Gallium is group 3. Group 3 is S2P1, but since it's -1, so it's going to be S2P2, right? So इसमें एक electron ज़्यादा. There's one extra electron in this. Now, do they have the same number of unpaired p electrons? I mean, now it's not that simple because the electronic configuration is different for both of them. So, but do they have the same number of unpaired p electrons? P4 means, what does it mean? It means that px, py, and you've got pz. So it's 2, 1, and 1. So that means they're 2 unpaired. P2 means px, py, and pz, and there's 1, 1, and 0, and it's still 2 unpaired. So remember, he was asking for the same number of unpaired. So they do have the same number of unpaired. Although the electronic configuration is different, but the number of unpaired orbitals is exactly the same. Clear hai baat? Is this clear?
Yes, sir.
So then you have the third one, which is phosphorus is group 15. So it's going to be S2P3. Neon is group 18. It's a noble gas. So it's going to be S2P6. But since it's +1, so it's going to be P5. So their electronic configuration is obviously going to be different. I mean, the number of unpaired, I mean, P3 means all of them would be unpaired. P5 means only one of them would be unpaired. The rest would be full. So this one is definitely wrong. Number 3 is definitely incorrect. And this is the box representation we had discussed. So 8 electrons. 8 electrons is going to be 1s2, 2s2, and 2p4. So it's going to be B. The first one is 1s2, 2 electrons, 2s2, 2 electrons, and the 2p is 4. So 2p will have 4 electrons, 1 in each, and then the first one would become paired. So 1s2, 2s2, 2p4. So this is the same, and so let's. So most of the questions are pretty much the same. Remember, they just talk about a lot about these unpaired p electrons, etc. So remember, make sure you know when a p is unpaired and so on. I'll just do this one last one. It's a very similar question we did earlier as well. So aluminium is group 3. So it should be S2P1, but it's 2 minus. 2 minus means it should be P1, but now it's going to be P3. Oxygen is group 6. So it should be S2 and P4, But since it's +1, so it would be P3 as well. So their number of electrons are exactly the same, which is why they're going to have the same electronic configuration. And so then you have nitrogen. Nitrogen is group 15, so it's going to be S2 and P3. And Cl is group 17, so it's going to be S2P5, but it's +2, so that means it would be it's +2, so that means it's going to be P3 as well. So they have exactly the same electronic configuration, which means they're going to have the same number of unpaired p electrons. Carbon is group 4. Group 4 is S2, P2. Cl is group 17, so it should be S2P5, but +1 means it's going to lose 1 electron. I said we did this already, that if you have P2 and P4, they also have the same number of unpaired electrons. This is something that we had done earlier. You got Px, Py, and Pz, so there would be 2 unpaired. If you have P4, you still have 2 unpaired. So all 3 are correct in this case. ठीक है, so we're gonna
MTF से फर्क तो नहीं पड़ेगा ना, मतलब उसका
unpaired means 1 electron in an orbital. ठीक है.
Okay, sir.
ठीक है. Unpaired means there's only 1 electron. I mean, there's no pairing. If something is empty, that means it doesn't exist. I mean, it has no existence. Like there's nothing there. ठीक है. So let's move on to. The only takeaway from this is, remember, writing electronic configurations is easy, but doing this quickly, that's more important. You don't have time. You're always running out of time. You have to be very, very quick. So make sure you remember all the shortcuts of how to write the electronic configurations. The next thing that we're going to focus on is ionization energies. Okay, just 1 second. Let me open the. I'll just give you a brief intro first. This is just a so ionization energies. Now, remember this, that when you talk about ionization energies, it's basically you trying to remove an electron from an atom. So if you have a sodium atom, sodium has in its nucleus, it's got 11 protons and it's got 12 neutrons. I mean, it's got many isotopes, but usually the most common one is this one. So that is what a sodium is. It's got a positive nucleus. So this one has positive charge, and there would be electrons in 3 shells around it. So you've got that's shell number 2, that's shell number. So that's shell number 3. So sodium would be 2 electrons close to the nucleus, 8 electrons slightly further away. And then there is 1 electron on the outside. So that is what sodium looks like. So what you're trying to do is you're trying to remove electrons. Now remember, all of chemistry is all about atoms losing electrons and other atoms gaining electrons or sharing electrons. So chemical reactions is all about, I mean, the nucleuses, and the nucleuses of different atoms are basically fighting over electrons. They're all trying to pull electrons towards themselves. So ionization energy gives you some properties about elements. What do they want to do? Like, how easy is it to remove electrons or how difficult it is to remove electrons. So you can pretty much judge the character of an atom, what it likes to do. Plus, you can also figure out the arrangement of the atom. Like if the electron is very far away, that would mean it would be very easy to remove electrons. So that will give you an idea of how far away the electron is or in what shell it is in. If the electron is very close to the nucleus, then it's very strongly attracted to it. So it's going to be very hard to remove that electron. So in ionization energies, you're trying to remove electrons, and any number of electrons you can remove, and you're trying to form ions. And when you have an isolated atom, then that atom is usually gaseous. So here's a sodium atom. They ask you to write equations a lot. Almost all paper, they ask you for an ionization energy equation. So if I try to remove one electron from sodium, the outermost one, then it would become sodium plus 1 gaseous, and 1 electron would be lost. Now this equation represents there would be energy needed for that. Remember, ionization energies are always endothermic.
Sir,
Hanji.
sir, in this, like we break the atom into an ion.
We turn an atom into an ion. We start removing electrons from it. The electrons are sticking to the nucleus, right? So one by one, we start removing electrons from the nucleus or from the atom. Clear? So over here, what I've done is I've taken a sodium atom and I've removed 1 electron from it. So the first electron, I've removed it. Okay, so let's say this electron over here is gone. So the shell is gone as well because there's nothing there now. And the sodium is now in the form of an ion. It's got a +1 charge. Okay, that 1 electron is now removed. It's an endothermic process because remember, you would have to give the electron energy. The electron would be very attracted to the nucleus. It would be buzzing around close to the nucleus, but you have to make the electron energetic so that it overcomes the force of attraction from the nucleus and it escapes. So the thing is that ionization energies are always endothermic. And this one is known as the first ionization energy of sodium. TK, is this clear? So this one is our first ionization energy. Then what you're going to do is you're going to try and remove another electron. So if you give this electron energy. How do you give an electron energy? Remember, energy is transmitted in the form of waves, and there are all sorts of waves. Everywhere energy is transmitted in the form of, it's either light or heat, or any electromagnetic wave. It's starting from radio waves to all the way to X-rays and gamma rays. You've got all sorts of frequencies. So these electrons, they gain energy from there, and this second electron escapes as well. Now the charge on this ion would be +2 because now it's lost 2 electrons. And that's known as the second ionization energy. So second ionization energy is that once the first one has been lost, remember the first one has already been removed. The ion now loses another electron and now it forms an Na+2 ion. And another electron is now lost. So that's the second ionization energy of sodium. Similarly, you're going to have a third one as well. A third electron would be lost, and the sodium ion would turn into +3. Remember, we're doing this artificially, so it's not going to happen on its own. We are forcing sodium to lose electrons. So one by one, we can strip sodium from all its electrons. So now you've got Na, which is +2, and it's lost another electron. And now Na is +3. And states, remember, states are very important when you write ionization energies, and the states are always, it's always gaseous ions. So that is what ionization energy is. You keep on removing electrons. In total, the number of electrons that you can remove in a sodium atom, there would be 11 ionization energies. So you can, I mean, this thing can keep on, it can keep on happening. You can keep on removing electrons. At the end of the day, there would be sodium, which will have a charge of 10 plus. And you, in the lab, you're going to try and remove another electron from this. So it would become sodium with a charge of +11. That means all electrons are lost. And the last electron is also lost. So this is known as the second ionization energy. This one over here.
Sir,
Hanji.
so ionization energy is based on how many electrons are there in an atom?
The total number of ionization energies is based on that. I mean, you can't remove 12 electrons if there are no 12 electrons, okay?
And sir, how is the process endothermic?
Because the electron is sticking to the atom, it's attracted to the nucleus. So why would the electron leave on its own? I mean, you would have to give it energy, you have to make it energetic so that this electron flies off, okay? So which is why you would have to give it energy. Otherwise, the electrons are naturally attracted to the nucleus. They won't leave the nucleus. Clear है?
तो इस तरीके से कह सकते हैं कि मतलब एटम ब्रेक हो रहा है तो इसीलिए एंडोथर्मिक है मतलब इलेक्ट्रॉन निकल रहा है ना मतलब
एक तरह से what you can state is के a bond is being broken. ठीक है कि nucleus and the electron were attracted to each other, and you're pulling this electron out of the or away from the nucleus. ठीक है, so there's kind of a bond between them. There's an attractive force between them, and you're breaking that attractive force. Is this clear?
Yes, sir.
So now the thing is, the first thing is you have to learn how to write the equations. So for example, they ask you to write this equation. Let's say they ask you that what's the fourth ionization energy of calcium? So how would you write the equation? So when you talk about the fourth ionization energy, that means 3 electrons have already been lost. And you're trying to remove the 4th electron. Okay, remember, fourth means you are the one trying to remove the 4th electron. 3 have already been lost. You've already removed 3 of them. And now you're trying to remove the 4th electron. So it would become calcium with +4. And it will have its gaseous. Okay, is this clear?
Yes, sir.
Okay, what if they ask you for, let's say, the 10th ionization energy of bromine? So can anyone tell me what is the equation? How would I write the equation?
BR plus 10, so we'll give BR plus 11 plus 1
No, 10th means you're the one removing the 10th. Abhi tak
plus 9.
ठीक है, so it's going to be
Plus
plus 9. ठीक है, it's going to be plus 9. You're the one trying to remove the 10th one. So it would become Br plus 10 gaseous, and one more electron would be lost. So remember, this thing should start from, it's lagging this. It's like if it's 10th, then over here it's going to be +9. If it's 4th, then it's going to be +3. You'll remove the 4th electron, then it would become +4. So just make sure, be careful with this. The second ionization energy of magnesium would be what? It would be if you given second ionization energy of Mg. I'm just going to write I.E now for ionization energy. So second means the first has been lost. You're trying to remove the second one now. So it's going to be Mg +1 and it will turn into Mg +2. And every time, remember, it's going to be just one electron that would be lost. Just similarly, they're going to give you questions. So this is the second ionization energy of magnesium. Similarly, they're going to ask you about, they'll give you an equation. Let's say they give you that calcium 1+ gaseous loses 2 electrons and turns into calcium 3+ gaseous. And now 2 electrons are lost. Now remember, ionization energies by definition is for removing just 1 electron from an atom or from an ion. It's always you're trying to remove 1 electron. Can anyone tell me how would you label this? Which ionization energy is this? Because you've gone all the way from 1+ to 3+. So which ionization energy is this?
Second ionization.
Second is when you remove just 1 electron from 1+ and you end up with calcium 2+. So, but you're going all the way to 3+. So that means you go to calcium 2+, but you remove the first electron. So it's the second ionization energy plus it's the third ionization energy. It's the sum of both of them. It's second ionization energy plus the third ionization energy. Why? Because you have to go all the way to calcium 3+. So the first thing you're going to do is you're going to go from 1+ to calcium 2+. That is your second ionization energy. Then you're going to take calcium 2+, remove another electron, and you'll reach calcium 3+. So that's your third ionization energy. So it's the second ionization energy plus so you would have to do 2 things. You would have to remove the second electron as well as the third electron. So it's the second ionization energy plus the third ionization energy. Is this clear, this statement, this one?
Yes.
So the first thing is you got to be sure about your equations. You can just be careful. What we just studied was that you just keep on removing electron one by one. It's always going to be a gaseous atom. What that simply means is that it's not bonded to anything. It's just an isolated atom that you've isolated in a laboratory, and you're trying to pluck electrons away from it. And one by one, you're removing electrons. You remove the first one, that's first. Remember this lags behind. I mean, the way you can figure out the ionization energy is by looking at this one. I mean, this is the 11th ionization energy because you've already removed 10. Now you're trying to remove the 11th electron. And you got to be, so this is something that you have to be very good with. And they're going to mix things up like this as well. So let's continue tomorrow now, TK, with the same, and we'll figure out factors that affect ionization energies. हाँ जी.
सर ये recorded lecture upload कर सकते हैं?
मैं कर देता हूँ. I'll share it, right. असल में 1 घंटे बाद ना रिकॉर्डिंग बनती है. What you can do is कि मुझे उस रिमाइंड करा दिया करो थोड़ा सा ना वो, क्योंकि रिकॉर्डिंग अगर अभी होती तो मैं शेयर कर देता, लेकिन इट्स गोइंग टू प्रोसेस और फिर वो बाद में होगी, तो मैं कर देता हूँ. ठीक है, ओके, अल्लाह हाफिज.